Hello class 10. Today's topic is change of state. We have already learned that matter exists in three states, namely solid, liquid and gas. The famous example for all these states is water. In solid it is found as ice. In liquid it is in the state of water, and in the state of gas it is a vapor. So ice, water and vapor are the three states of the same element, that is water. Okay, so ice, when it is heated, gets converted into water, and water on heating becomes vapor. So the process of ice getting converted into water is called melting. Similarly, water getting converted into vapor, the process is called vaporization. Now, these states of matter can again be uh, reversible. It can be reversed back. So, the vapor can be reversed back to water when it is cooled or when the heat is taken out from vapor. Okay. Again, similarly, water can be formed to ice when it is cooled. So when the vapor gets converted into water, the process is called condensation, or also called as liquefaction. And when water gets converted into ice, the process is called freezing. In some of the cases, sometimes solid directly gets converted in gas. This process of conversion from solid to gas directly without passing through the liquid phase is called sublimation. The reverse process, that is gas getting converted directly into solid without passing through the liquid phase, is also called as solidification. The example of sublimation is dry ice. Dry ice is a solid and it gets converted directly into the gaseous form. So this is the example of sublimation. The second example is the formation of frost. Air, when when air gets in contact with the objects which are less than the freezing temperature, the water molecules in air directly gets converted into the ice, Okay, this is the formation of frost, and this process is also called as deposition. Now let's learn about melting. Let's say there is a solid, and when it is heated, the temperature of this solid will increase. So the temperature increases up till it reaches a certain temperature, after which the temperature remains fixed. At this time, the heat being supplied will be used in order to change the state of matter from solid to liquid. So this process is the process of melting, where at a particular temperature, after reaching a particular temperature, the temperature won't increase, but the heat during this time, the heat energy will be required in order to change the state from solid to liquid, which is called as melting. So melting is a process of change of state from solid to liquid by absorption of heat at a constant temperature. So the temperature has to be fixed. So this fixed or constant temperature is called the melting point of that solid. Freezing. So now let's say that there is a liquid and the heat is taken out from this liquid, or it is cooled. When it is cooled, the temperature will be dropped, or the temperature decreases, and it will keep on decreasing until there is a certain temperature after reaching at which the temperature remains fixed. So at this particular point, the heat which is being extracted out of liquid will be used in order to change the state of liquid back to solid. So freezing is a process of change of state from liquid to solid by liberation of heat at a constant temperature. So this constant temperature is called the freezing point of the liquid. Here we need to remember that for a given mass of substance, heat energy absorbed during melting will be equal to heat energy liberated during freezing. So both the heat energy has to be equal, the one which is absorbed during melting and the one which is liberated during freezing by the same substance has to be equal. Vaporization or boiling. So let's say a certain mass of liquid is heated, and when it is heated, the temperature of the liquid will increase. So the temperature increases, and after reaching a certain temperature, the temperature won't increase further, rather the temperature remains fixed. So the heat energy which is being given or supplied to the liquid, instead of rising the temperature, that heat energy will be used in order to change the state of liquid to gas. So this process is the process of vaporization, where the heat energy will be used in order to change the state of liquid to gas without changing the temperature or at a fixed temperature. So vaporization is a process of change of state from liquid to gas, or simply vapor, by absorption of heat at a constant temperature. And this constant temperature is called the boiling point of the liquid. Condensation or liquefaction. So here let's say a certain mass of gas is taken and its temperature is dropped by cooling the gas. So the temperature decreases, and again the temperature remains fixed after a certain decrease of temperature. It remains fixed, and at this point the heat being withdrawn or liberated from gas will be used to change its state from gas to liquid. So the condensation or liquefaction is a process of change of state from gas to liquid by liberation of heat at a constant temperature. This constant temperature is called the condensation point of the vapor. So here again we need to remember that for a given mass of substance, heat energy absorbed during vaporization is equal to heat energy liberated during condensation. The next is heating curve for water. So here is a graph which shows temperature in y-axis and the heat energy supplied in the x-axis, or we can also use time in x-axis. So here heat energy is used in x-axis and temperature is used in the y-axis. So when ice is taken and it is supplied with heat, okay, at first let's say the ice is at minus 100 degrees Celsius. So when it is heated, the temperature of ice slowly increases as the heat is being added towards the positive x-axis. The temperature rises of the solid, that is ice, and it reaches 0 degree Celsius. So at this point we can see that there is growth, or there is the graph increases as the increase of heat. Okay, as heat increases, the temperature also increases, so there is a positive growth in the graph. But after reaching 0 degree Celsius, when you supply more heat, there is no growth, or there is no uh, gain in temperature. Okay, the temperature is not increasing, rather it remains fixed for a certain time. So at this particular at this particular point from here to here, the heat is being absorbed by ice in order to melt. So as the entire mass of ice is melted, so from this point onwards, further application of heat will change its state from solid ice to liquid water, and then again the temperature of the liquid water will increase from 0. With more heat, it will move on to up till 100 degrees Celsius. While it reaches 100 degrees Celsius, on application of more heat, it won't increase to more than 100 degrees Celsius. Rather, it stays same and constant until and unless the entire liquid changes its state from liquid to gas. Once the entire mass of water is converted into gas or in the vapor state, then the further application of heat will increase the temperature of that gas from beyond 100 degrees Celsius. So this is how we understand the heating curve for water. Okay, if you only take the heating curve of water, then it will start from the melting of ice and the formation of liquid water, and then it goes up till 100 degrees Celsius, and reaching 100 degrees Celsius, on further application of heat, the temperature remains fixed. It won't increase from 100 until and unless it reaches a certain point at which the entire mass of water gets converted into gas, and then on further application of heat, the temperature of gas will increase. So only this portion of the graph can be considered as heating curve for water. But here the entire graph shows how water in the state of ice, in the state of liquid water, and in the state of gas as a vapor, how it shows its behavior is shown by this curve, heating curve for water.